Today, we would like to talk to you about an important project called Flood Rainfall Disaster Prediction. This project is aimed at predicting natural disasters such as hurricane, floods using machine learning models. We are basically focusing on flood and rainfall. So the we have some table contents here. The first one is introduction. Second is problem statement. Third one is project module. Fourth is technology and tools which you are using. Fifth is hardware specification on which this project can run on. Sixth is the business model. Seventh is the impact on the business. And eighth is the challenges we faced. So coming on the introduction, the Flood Disaster Prediction Project is an innovative initiative that uses statistical model, learning theory, and the FLAS web framework to predict potential flood disasters. This project was developed with the goal of providing early warning alerts for floods in vulnerable communities, helping people prepare and protect themselves from any potential flooding. The data used in the prediction system came from various sources such as satellite imagery, ground-based sensors, weather forecast, GitHub repository, and etc. Second, the problem statement is key. We need to find a disaster prediction using rainfall analysis and flood prediction. And the project modules which we are going to discuss will be talked about. Sayo will be the project modules which we'll be talking about will be told by Sayog. The technology and tools which will be used are the environment which will be required to run this project will be Python 3.6. Python 3.6 libraries which are required are Keras, TensorFlow, Scikit-learn, Pandas, NumPy, Matplotlib, Seaborn, and Ambilearn, which also uses Smote, SMOTE. And tools, we are using our FB Profit, which is a framework for time series, and Flask and WT forms. The UI which we are using are HTML, CSS, and Bootstrap. The hardware specification which we require is Windows 7, Windows 8, Windows 10, and it can basically run on all the computers with all and are applicable on all the browsers. The business model will be told by Aditya, and now moving forward, the business impact will be told by Aditya again. Now moving forward to the challenges that we faced, it will be told by Shabanya. Now moving forward, we will talk about the code which we have implemented and what's going exactly there and how did we build the model.
The project models used are mainly Pandas, Datetime, Time, Matplot, sklearn preprocessor, sklearn utils, sklearn metrics, NumPy, Seaborn, Chart, Studio.pylab, Jobline, Warning. So the main modules which are mainly used from the above are Pandas for date manipulation and analysis, date time for working with dates and time, matplot for data visualization, sklearn metrics for evaluating model performance and preprocessing of data, numpy for numeric computation. And the technologies and tools used are environment is Python 3.6. Python libraries are Keras, TensorFlow, Pandas, NumPy, Matplot, Seaborn. And the tools used are Flask with forms. UI user interface tools used are HTML, CSS, Bootstrap.
I'm going to now explain about the business model. Uh, the business model includes the government can use this model to forecast flooding and rainfall in different country-wide risk areas in advance so that precautions can be taken. An early warning system and disaster prevention could benefit from efficient real-time flood forecasting models. And precipitation forecasts can also be used in flood forecasting in an effort to increase the amount of lead time available. Analysis of rainfall can aid in forecasting agricultural yield and regional gross production value. Now I'll explain and talk a bit about the business impact. A different approach would be to add variables like humidity, wind direction, location, etc. to the data set. Uh, One more point is that the government can use the model to deploy early warning systems in flood-prone areas, and it can be used to make quick decisions about disaster-resistant actions. And when applied to a range of industrial businesses whose goods are impacted by rainfall patterns, it'll be really useful. Thank you.
So here we have the code for the model. So now, of course, we are importing all the libraries which is required for the code, and we are using the flood classifier, which you can see is here. Okay, and then we are breaking down the columns in all the data using timestamp and scaling the data from the range of 0 to 1, whether the flood is occurring or not. If flood is occurring, it's we have taken it as 1, and the flood is not occurring, we are taking it as 0. Now we are using slicing and indexing for the data set, which we have here in the form of CSVs and all. As you can see here in the trained, not in a trade, in the data set. Like here you can see XLXX. Here you can open it up and you will be able to see the subdivision CSV, which we, if we open it, it will be in the form of this. It's a huge data set which we have formed by ourselves. You need to clean it up, and structured format is required so that the model can be run properly and it can be without any error. So moving forward, the given code is basically a machine learning model for flood classification. So the model uses various libraries such as Panda, Matplotlib, Skylern, Seaborn, Chart Studio, and Joblib. So Joblib, as we can see, you can use it using Skylern.externals import Joblib also, but depending on the Python import and depending on your pip library. It depends whether you can learn it, like run it on Python 3.6, and if you are using something called Python 3.9, it will be a bit hard because that doesn't contain Skyline externals. So you need to be aware of what kind of environment you are using, whether it works on Python 3.6 or Python 3.9 or any other else. Okay, so depending on that, all the codes will be working. So the first part of the code involves loading the necessary libraries and reading the data from the Excel file. Then the data is then pre-proposed by filling the null entries with the mean of their respective columns, as you can see here. So we are filling the respective columns with the mean, and the flood column is then converted to a binary value in the scale of range, as you can see here. And then the while and again I told you that there is a flood and it indicates 0, and if there is no flood, sorry, if there is a flood it indicates 1, and if there is no flood it indicates 0. The data column is then broken down into years, months, and day to extract useful information. Now the second part of the code involves the resampling the data, dropping the data column, and scaling the data with the range of 0 to 1. Here, as you can see, the unsampling sport. Yeah. And the third part of the code involves training and testing various machine learning models such as logistic regression and linear discriminant analysis, as you can see here, and then saving and loading the model which is present here. And we are also use you can also use k-neighbors classifier and you can test it. Now, if you go to the model comparison and confusion matrix, here we can see key we have data discharge and as well as the data and data fill now. As you can see, how many columns are empty and which columns are not empty or row, etc. And moving forward, you can go and see this is the basic EDA we are this data analysis we are trying to do here. So this is a histogram for the data size. And moving forward, देखो कुछ कुछ चीजें काटने होंगे, okay? You need to cut it. तो yeah, so we are now trying the binary classifier. So we are importing all the files which is required here, and we are using spot check algorithms to check the whether check the code in all the models and finding the accuracy on all the models. So as you can see, decision tree classifier is working a bit too well, but depending on the data, there can be an error and accuracy may increase. So we cannot really say that this one is right. While KNN LDR is working very nice, it's giving us an accuracy of 98.82 and 98.52 respectively. So if we are comparing the algorithms, we can find this in the algorithm comparison format. So this is for our and this is for the linear discriminant analysis. So it's giving us an, of course, accuracy of 0.97 with precision of 0.35 and a recall of 1. F1 score is 0.52 and support is 25. So this is what the code is, and if we are trying to run this on just one thing. Yeah, you need to remove it. I mean, of course. I'm like here. I just need to run one more. Once this code is done, I will just show them what's the front. And that's it, will be done. So here we are trying to run the code and the front head. So just wait for a while. You have to run Python space main.py and then start to run the code. Okay, so here it goes. So this will be your interface from where you will be connecting the HTTP, the HTML will be rendering here from that IP address from the and rainfall prediction. As you can see, you can just go here, choose some subdivision here, just take it as a 1911 and send, and just wait for a while. You will get this. And the backend, as you can see, if you want to see in the backend, it will be doing some vpokes here. The data set was trained here, and you can find the accuracy basically there. So this is it.
The challenges faced during this project were the collection of trustworthy data from various sources, deciding on a particular machine learning model for achieving maximum accuracy without overfitting the data, prediction of flood based on reverse discharge and daily, weekly runoff, analysis of river pattern based on acquired data set, improving the accuracy of the model with limited data sources available, and integrating the model with an user interface. Thank you.